Welcome to my channel once again. In today's topic, we're talking about combustion reaction. Combustion reaction. What we mean about combustion reaction, these hydrocarbons, they burn in air to give two major products. So when they burn in air, they burn in excess oxygen to give two major products known as carbon dioxide and water. That is to say, when an organic compound is exposed to air, it undergoes combustion reaction. And when this combustion reaction occurs, it gives two stable compounds. So in this now, for instance, let's use a very simple organic compound. Let's use methane. When you react with oxygen, we said it must be in excess for this reaction to be in a completion. We said it gives two major products, carbon dioxide plus water. So our ability to balance this equation is very important because excess oxygen is used in the process. So by so doing, the first method in balancing combustion reaction is to balance this carbon followed by hydrogen. The next, we can manipulate this single molecule that is here, oxygen, for us to have a balanced equation. By so doing, we say we have one carbon here, we have one carbon here. Let's try to balance this equation. We have one here, we have carbon here. So by so doing, if we should have this, what is here? We said we have 4 hydrogen. Say we have 4 hydrogen. How can we balance this hydrogen? We must make sure that we have 2 here. 4 divided by 2, we are going to have 2. So when we multiply 2 times 2, it's going to give us 4 hydrogen. So the next is oxygen. If you check here, we have 2 oxygen here. We have 2 oxygen here. Oxygen here is 4. Oxygen here is 4. For us to have, well, it said oxygen here is 2. For us to have 2, if we should multiply here times 2, it's going to give us 4. So this is a very simple way to balance a combustion reaction involving hydrocarbons. We already know that any hydrocarbons, when they burn in excess air, they give birth to carbon dioxide and water. So let's move to a more complex reaction. So when we have an aspect that will have an odd number, let's use C. We have used CH4. Let's use C2H6. We are going to use C3H8. Let's use C4H10. Okay, let's use C2H6 reacting with oxygen. We're going to give birth to CO2 plus water. So in this aspect now, we say we must balance this carbon first. We say carbon here is 2. So let's balance this carbon. For us to balance this carbon, we're going to add 2 here. C is equals to 2 as well. We say what is next is hydrogen. Hydrogen on the reactant side, it said is 6. It has 6. So here, hydrogen here is 2. 6 divided by 2 is 3. If we should add 3 to this place, we're going to have 3 times 2, we're going to have 6 as well. So if we should calculate the carbon here, we should calculate the oxygen. The oxygen is 4. We have 4 oxygen here. 2 times 2 is 4. We have 3 oxygen. That is 7. That is 7. So oxygen here is 7. We said here, it took 7 divided by 2. We are going to have 3.5. 3.5. So what can we do here? Let's say if we should have something like 7 all over 2, it will give us this 7 at the product side. But in this aspect, we cannot leave our equation in a fraction. So we're going to multiply each unit by 2. We're going to multiply each unit by 2. What can we do here? We say let's have something like this. Let's multiply through by 2. We're going to multiply through by 2. So here we're going to have, let's have 2 times this group, that is C2H6, going to have plus 2 times 7 all over 2 oxygen. We're going to have 2 times 2 CO2 plus 2 times 3 molecule of water. By so doing, we have said this 2 is affecting this compound. We're going to have 2 C2H6 plus 2 divided by 2. 2 cancel 2 here. You're going to have 7 mole of oxygen to give 2 times 2, you're going to have 4 CO2 plus 6 H2O. By so doing, this is a very simple method at which you can balance a combustion reaction involving an odd number. We multiply through by 2. So by so doing, we said, let's count the number of these atoms. So let's say CHO. Yeah, we said 2 times 2, you're going to have 4. We have 4 here. 6, that is 12. 2 times 6 is 12. Oxygen is 14. Oxygen is 14. Yeah, we said carbon is 4. 4 times 1. We said hydrogen, 6 times 2 is 12. We said oxygen, 4 times 2 here is 8. 8 plus 6 is 14. 14. So here we have 14. So with this method, we can use this method in a very simple way to balance our equation, especially when it involves stoichiometry equation, so that you don't have you not waste time during balancing this chemical equation, so that you can continue solving. This will help us in a proper way during multiple choice questions for us to have a better idea of combustion reaction. So let's move on. Let's try. Let's leave alkane family. Let's try something different. So let's use C2H5OH plus oxygen gas. So yeah, it must give as well carbon 4 oxide plus water. So what can we do here? We must balance. It's a simple way as well. Since we have hydrogen here, oxygen here, it will be more easier for us to balance this kind of equation involving organic compounds. So in this now, we said we must balance the carbon first. We said carbon here is 2. Yeah, carbon must be 2. We must balance this carbon to be 2. We said carbon is 2 here. So we're going to balance the hydrogen. Hydrogen is 5 here plus 1 is 6. Hydrogen is 6 at the reactant side. Hydrogen here, we are left with only here. We say hydrogen for us, 6 divided by 3. 6 divided by 2 is 3. If we should multiply 3 times 2, it's going to give us 6. 6 aspect. So here now we have 2 times this is 4. 3, we have 7 here. 7. We have 3 here. That is 7 oxygen. Said oxygen at the product side is 7. We said oxygen here will not be what? Yeah, we said we have 1 oxygen here. We should, yeah, that is 3. We have 3 here. If I should multiply this, for us to have, since we have 1 here, we can multiply it to have 6. So for us to have 6, we're going to multiply this side to be 3. 3 times 2 is 6 plus 1 is 7. So this will be the end of this reaction. We said when there is an organic, let's recall when when organic compounds react in air, in excess air, it gives 2 major products. But these major products, we must have excess air for this product to be obtained. So if the reaction does not actually involve excess air, you are going to have different product as well. Please make sure you balance this equation when you are solving stoichiometry equation, or when you are asked to balance combustion reaction. You can use these methods to balance all combustion reaction. Please do well to subscribe to this channel and as well share this video. Thank you for watching.